Okay, I want to talk to you a little bit about monatomic ion nomenclature. Okay, now that term nomenclature, it really is referring to naming things or writing chemical formulas. So interconverting between chemical formulas and chemical names. Okay, that's what that term nomenclature is referring to. So we're going to talk about the systematics of how we deal with monatomic ions. Now, a monatomic ion is simply one atom that has a charge, okay? And that charge could be some sort of positive or some sort of negative charge. And the reason it has that positive or negative charge is because the neutral atom either gained or lost electrons. If you have a neutral atom and it loses electrons, it forms a cation. If you have a neutral atom and it gains electrons, then you have an anion, okay? So for instance, if you have a sodium atom, if something is around that wants electrons, the sodium atom will give it an electron because a sodium atom, when it's neutral, thus the reason I call it an atom, uh, that isn't the most stable it could be. It favors losing an electron. So it can lose an electron and form then a positive charge, forming what we call then a sodium ion, so an Na plus. Whereas if we had, say, a chlorine atom, when you have a neutral chlorine atom, it really has one more, or I'm sorry, it needs one more electron. So it really is lacking. And so if there's something around that's willing to give it electrons, it will take an electron. And if a chlorine atom takes on an electron, it forms what we call a chloride ion and has a formula of Cl minus then. So it is then an anion. Okay, so you can have cations form when things give up electrons. You can have anions form when things take on electrons. And so if you have sodium atoms and you have chlorine atoms, so neutral atoms of those, then the sodium atoms will happily give an electron to the chlorine atoms, okay? Because then both of them gain. Both of them are in a better, they're in a better scenario at that point. They're at a lower energy state. So when we're dealing with these types of ions, where it's just one atom that lost or gained electrons, we have a systematic for naming them, okay? Or there's a couple systematics, I should say, depending on what type of monatomic ion you're dealing with. So we can have cations, there are monatomic cations, and if we have cations, there's actually two different systematics because there's kind of two types of monatomic cations. You can have monatomic cations that only have one possible charge, and you can have monatomic cations that can have multiple charges. Okay, so you have this neutral atom, and some neutral atoms favor giving up a certain number of electrons, meaning if they give up that certain number of electrons, they only form one specific charge. Okay? Whereas some neutral atoms, they are willing to give up multiple number of electrons. And so you might have this atom that's willing to give one electron away and it's happy there, whereas it's also willing to give away two electrons and it's happy there. So it just depends specifically on the electronic structure of that atom, which is going to be dependent on what element it is. Okay, so there's just naturally atoms of certain elements that favor giving up only one specific number of electrons and some that kind of are, I guess, indecisive. They're willing to give up multiple possibilities of electrons. Okay, and so those we name differently, and it's because the ones that give up multiple numbers of electrons, we're going to have to specify which scenario we're talking about. Okay, so if something only forms one charge, if this cation only forms one charge, meaning this is an atom that is willing to give up one electron and one only, or this atom is willing to give up two electrons and two only, or three and three only, then that's something we know because that is specific behavior of that element that we always see. And so to name that, we keep it very simple. You use the element name and you add the word ion. That's it. So for instance, sodium. Sodium is willing to give up, a sodium atom is willing to give up one electron, and that's it. And so when sodium forms an ion, it forms Na plus, and that's the ion it always forms. And so we just simply call that sodium ion. Whereas you can have lots of other elements that are willing to give up multiple numbers of electrons. So say, for instance, copper. Copper is an element that has atoms that are willing to give up either one electron or two electrons. And so if you have a copper atom and that copper atom ends up giving away one electron, then it's going to form Cu plus. And so that particular copper atom is going to be called, or now copper ion, is going to be called copper 1 ion because it only gave away one electron. And here to help out, maybe I should write this down. So this example, I'll go ahead and write down when we have sodium, sodium can form only sodium ion. Okay, so Na plus, and so that would be sodium ion. But as I was saying, copper is an element that can form more than one possibility. So copper is Cu. So copper can give up one electron forming Cu plus, okay, or it can give up two electrons. So it can be Cu2 plus, okay. So what I have here is the systematic for when we have a scenario like this. And so here I say it's the element name, then the charge in parentheses, and then ion. But you have to be careful here. The charge, that needs to be in Roman numerals. Okay, so here, when I say that Cu plus would be copper 1 ion, that would be copper, oh, oops, not copper, copper with an O, and then 1, Roman numeral 1, ion. Okay, whereas Cu2 plus, a particular copper atom that gives up two electrons and forms Cu2 plus, would be called copper 2 ion. Okay, and so that's your basic systematic, how you deal with that. Now, it can be tricky to know which of these systematics do I use to name this particular cation that I'm given. Well, that's where the periodic table will come in handy. There's different areas of the periodic table where these things tend to only form one ion, and then areas where these things tend to form multiple. So it's helpful to look at periodic tables that have ions shown on them so you can get an idea of those patterns of where things are. I can tell you for sure, group 1 and 2 elements, those metals tend to only form one charge, or I shouldn't say tend to, they do only form one charge. Whereas transition metals, a lot of those tend to form multiple charges, okay? So there's a lot of patterns to this if you actually look at the ions on the periodic table. That should help if you find, a periodic table with ions displayed on it. Now let's talk about the basics of anions. So we can also have anions that are monatomic ions. Okay, so remember, this is all ions that contain one atom. Okay, it's one atom that has lost or gained electrons. And so to name a monatomic anion, you would take the element root name, when I say root name, I kind of mean the beginning, okay, the beginning of that element's name. And then you add ide as an ending, IDE, and then you add the word ion, okay? So, for instance, if we had, say, Cl, so chlorine, a chlorine atom is going to form Cl minus. It's going to pick up one electron. And so that, well, I have chlorine, and so we're going to kind of drop the end of that name, and we're going to tack on ide to the end. And so what it turns out being instead of chlorine is chloride. Okay, and then the word ion. And so another one, if I had, say, sulfur. Sulfur is going to form a 2 minus. So sulfur likes to pick up 2 electrons. And so that, again, you think about kind of the element name, and some of the letters fall off the end. I'm sorry, there's not a definite, you take off this many letters. It just is enough till it sounds kind of good, I guess. And so for that, it ends up being sulfide. And so they drop the UR off of that. Okay. And it turns into sulfide ion. So that's your general pattern of any monatomic anion. Okay. So all of these just show you the basic systematic. So you don't always have to have all of the ion names memorized if you recognize the typical pattern that something should follow. Okay, and you can apply then that pattern. Or sometimes it'll help you start to memorize some. Okay, now let's look at some of these ions on the periodic table. So like I said, it can be helpful to find a periodic table that shows you ions. Okay, so a typical periodic table, it's element symbols, atomic number, and atomic mass, right? But you can find different variations of the periodic table with ions listed on it. And like I said, that's to kind of help you see patterns in the charges that things form and whether or not something forms one charge or multiple charges. So this periodic table gives you some single charge ions, okay? And it includes both cations and anions, right? And the anions, the monatomic anions only form one charge, but the cations, there's some that would form multiple, and those aren't included on this particular table. Okay, now this is not all of the single charge ions, but these are some really common ones. Okay, others that aren't indicated here are elements that you typically don't run across in, say, an intro or a general chemistry type class. So when you look at this, what you should see is there are patterns to this. Okay, so like the first column, you get all of these, group one, those all form a +1, right? And then you look at the group two ones, those all form a +2, okay? And those are all only one charge. There's no multi-charge elements, you know, ions in group one or group two, okay? And then we have, say, okay, sorry about that. Okay, let's see. Anyway, so group one and group two, they only have one charge, and so those would be named with the basic systematic of name the element and write ion after it or add ion after it. Whereas if you go over to the non-metals, you could look at all of the halogens, all of these halogens, those all have a -1, right? And then all of the ones one over from the halogens, even this semi-metal has a -2 when it forms an anion. And then when you're 3 over from noble gases, then you have -3 charges. So you can see patterns on the periodic table of these charges. And since those are all monatomic anions, those you name with the "-ide", or the element name with an "-ide" ending, and then the word ion. Okay. And then in the center, kind of the transition area, there are a few indicated here that are pretty common ones that only have one charge. So aluminum's something that comes up a lot. It only forms a 3+. And then zinc, silver, and cadmium, those all only form one charge. A lot of the others that are left off of this table form more than one. So again, a reminder, your systematics. For your cations that are single charge, you name the element and add the word ion. And then for the anions, it is adding the "-ide" ending and then ion. So I've got some examples of these. So as I put up here, we've got calcium ion, that would be Ca2+. Okay. Or zinc ion, that would be for Zn2+, right? So it's just the element name in the word ion. Whereas, as I was saying, anions, it's the element root name plus "-ide" plus ion, okay? So for instance, if we have this N3-, well, that's nitrogen, right, is the element. And so I change the ending to "-ide" and add the word ion. So nitride ion. Or if we look at Br-, that would be bromide ion because that's bromine. So we change the ending to "-ide" and add the word ion. And so that's your systematics for your single ions. And then next up, multi-charge. Okay, so again, like I said, it can be helpful to look at periodic tables with the ions on them. So you can find where are these, and even sometimes you can start to recognize patterns and what charges they form. Okay, now this one, again, it doesn't have all the possible multi-charge cations, but it's got some very common ones that you tend to run across in chemistry a lot. So with this, the systematic, when you have multiple charges, is you name the element, you put the charge in Roman numerals in parentheses, and then you add the word ion. Okay, and so that's for any metal that forms multiple cations. Okay, so for instance, if we look here at the Cr2+ and the Cr3+, that's two different ions formed by the same metal. Okay, so two different cations, two different charges. So both of them are named chromium, right? But the first one, it has a 2 in Roman numerals, and the second one has a 3, okay? And then the word ion at the end. And so you do that for all of those that have multiple charges. Another one, if we look over here at lead, we've got Pb2+ and Pb4+, so two possible charges. And so you name the element, lead, okay, and then you say which charge. So it's either 2 or 4, and then the word ion. Okay, so that is kind of your basic systematic, and when you're trying to learn nomenclature, that can be very helpful because you don't always have to have all these names memorized, and you don't always want to rely on looking up every single name of things. And so understanding the systematics can really help you to just be able to name these things or even figure out the formula off the top of your head, because you should also be able to reverse this process. If you're given the name, you should be able to go back and figure out what is the symbol for this ion.